All right, this is grade 6, unit 1, lesson 6, and in this lesson, students are just going to continue practicing finding the area of parallelograms. There's some sneaky stuff. Occasionally, students are going to be given the area, and then they have to use division to find one of the missing lengths, either the missing base or the missing height. So let's get started. So as we look at this, all right, here we are. We're going to begin with the classic warm-up. It's counting dots, missing dots, and the idea is we want students to be able to count these dots without counting. So we want them to use some sort of efficient shortcut, and so we want students to kind of clump those dots together, and maybe they'll say, well, I see this clump of dots, I see this clump of dots, I see this clump, and this clump, and then they might add them together. So that's one idea for how students might approach it. Another idea that students might approach it is they might say, well, I see the entire collection of dots, but I see that we're missing this 2x3 collection of dots. So that's another way. And the idea is for students to get creative and find a bunch of different ways for how they might count all the dots in this figure. There, I can't help it, but there's at least one other way. There's one other way. Here's this. I see a big old clump right there. I see a clump right here, and then maybe even I can just by inspection see that there's 6 right there. So there's a variety of ways for how students might see the dots in that figure and then count them. So now for the activity. Let's see, I don't remember how many activities. I'm taking a sneak peek. Yeah, we're really just doing one activity, and this is really where we're just kind of consolidating everything that the students are working on. So it says find the area of each parallelogram, show your reasoning. So we have to remember that the formula for the area of a parallelogram is base times height. We see the base here is 10, we see the height here is 6. So the area of that parallelogram, it's not units, it's centimeters squared. All right. So here's a tricky one. So where's the base? Where is our base and corresponding height? We need to find it. Well, if this was the base, then the height needs to be perpendicular. We learned that from our previous lesson. And I don't see a value for this green height. So we definitely know that it can't be the 10, which is the base. So maybe it's the 15. So if that's the base, then the height would have to be perpendicular. And there would be the height. And, oh, there it is. It's 8. So we can see that the base is 15. The corresponding height is 8. So the area is base times height, which is 15 times 8, which is 120 centimeters squared. I don't like that. It's an open circle. All right. C, we need to find the base and the corresponding height. And in this case, the base is right here, the 9. The corresponding height is right here. It's 7. We can see that it's perpendicular. Right there is where it's perpendicular. So the formula for area of a parallelogram, base times height, which is 9 times 7, which is 63 centimeters squared. Now, really, if I really was going to be precise, I really should put 9 centimeters times 7 centimeters, and it's the centimeter times centimeter that gives us the centimeters squared. But I'm just walking teachers and parents through this process to kind of get a quick glimpse at what's going on here. For this parallelogram, nothing's labeled, but they gave us the grid. So we can see that the base is right here, and it's 1, 2, 3, 4, 5, 6, 7. So the base is 7 units. And we can see the height is right here. And it looks like it's 1, 2, 3, 4, 5 units. So our area is base times height, which is 7 units, times 5 units, which gives us 35 units squared as our area. So it says in parallelogram B of the first question, so that previous one we just did, what is the corresponding height for the base that is 10 centimeters long? So we're going to go back up here and, oops, actually it turns out I sort of answered it. So they're saying if 10 is the base, what must be the height? Well, we know the height must be perpendicular right here. And right now, we don't know what the height is. They did not give us the height. They didn't give us the height anywhere, right? But that doesn't mean we can't answer the question, because remember, we know that the area of this parallelogram is 120 square centimeters. So if the area of that parallelogram is 120 square centimeters, and we know that the base is 10, we can use a little bit of division to find that missing value. So let's do it. So we know that the area of that parallelogram, and I'll kind of draw it right here, we know that the area is 120 centimeters squared. We know that this base down here is 10 centimeters. So area is equal to base times height. We know that the area is 120. We know that the base is 10, but we don't know what the height is. So using a little bit of division, we could see that the height must be 12, and it must be 12 centimeters. Wow, that was kind of sneaky. Number 3, two different parallelograms, P and Q, both have an area of 20 square units. Neither of the parallelograms are triangles, and we're supposed to draw these two parallelograms. So we know if a parallelogram has an area of 12 square units, we know it could have a base of 4 and a height. Well, yeah, I reverse it, but it could have a base of 5 and a height of 4. I guess it could have a base of 4 and a height of 5, but that's not what I meant to say. I meant to say it could have a base of 5, golly. So it has a base of 5. So there's my base of 5. And we know it's going to have another base of 5, so I'm going to just copy it. There it is, and it's going to have a height of 4. So here's our base of 5, and here's our height of 4. But they said it cannot be a rectangle, so that's cool. I'm just going to slide this along a little bit. Boom! And there is my parallelogram with a base of 5 units, a height of 4 units. Boom, 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 boom. And there's my parallelogram with an area of 20 square units. Now, I could draw a second triangle, parallelogram, and it could have the same base and height. It could have the same base of 5. It could have the same height of 4. So there's my other base of 5 right there. And you can see here's my height of 4. But this time, I could really slide it and stretch it out, and all of a sudden, I've got a different parallelogram, but still with that area of 20. Now there's other ways I could, so that has a base of 5 and a height of 4 units, dot, 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 dot. There we go. Okay, so now I could have done like, I could have done a base of 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then a height of 2. And then I could have slided or slid, I don't know what the right answer is, right word, and slide that base a little bit. And now I have a base of 10 and a height of 2. All right, so I could have done that, but it's really kind of interesting to see that you can have two parallelograms that are totally different, and yet they have the same base and the same height. And I think that's kind of cool. All right, so this area, this one was tricky when I first peeked at it. And it says, okay, here's a parallelogram composed of smaller identical parallelograms. Find the area of this unshaded portion right there. All right, so let's delete that little oopsies. Delete. Yikes. Delete. There we go. All right, so we're going to do a little bit of math to find the area of that simple parallelogram right here. Boom. So I could see that my base is 5, my height is 2.4, so the area is 5 times 2.4, which gives me 12 square units. I think we're going to call them, yeah, we're going to call it 12 square units. So we know that this area right here is 12, which means we automatically know that this area is 12 because they're identical parallelograms. We know that the base of this parallelogram is 3, which means its height, which has not been given to us, but the height is right here. There is the height, and we know that the height must be 4. And why do we know that it's 4? Well, because we know that this parallelogram has an area of 12 square units. We know that the base is 3, and since the base is 3, that means the height must be 4. We don't care what this length is right here. We don't care. All we care about is the height and the base. All right. So now we know that this area of this parallelogram is also 12. Let's see if that matters. No, that doesn't really matter, but let's do it anyway. and then this area. Now, we know that this area is 12, but right now what we really care about is the fact that the height is 2.4. Why do we know that the height is 2.4? Because it was 2.4 over here. And since the height over here is 2.4, and this is essentially the same parallelogram just translated up, we know that that missing length right there must be, and I'll do dot, 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 that must be 2.4. So we can see that the height of this entire parallelogram is 6.4. How do we know that it's 6.4? Well, because we added the 4 here and the 2.4 here. So that height of the parallelogram is 6.4. We know that the base of this parallelogram, when I say parallelogram, I'm now talking about the huge parallelogram. We know that the base is 8. And since the base is 8 and the height is 6.4, all we have to do is find the area by multiplying 8 times 6.4. And I don't know, let's do it down here. 6.4 times 8, 32, 48, 49, 50, 51. So the answer, the area, is 51.2 square units. All right, yay. Now that's the area of the big, huge overall parallelogram. The combined area of the 4 green ones is 12 plus 12 plus 12 plus 12, so that's 48. And so we know that the 4 green ones is 48, so all we have to do is 51.2 minus 48, and that's going to give us, 51.2 minus 48. Oh man, 51.2 minus 48. 3. 3.2. So we know that the area of this little triangle, a parallelogram inside there, this little area right there. In fact, I shouldn't do green. Let's do a different color. Let's do orange. All right. So that orange piece has an area of 3.2 because the whole parallelogram has an area of 51.2. We know that the 4 parallelograms, the 4 green parallelograms, have an area of 48. You subtract the 2, you get 3.2, and that's that missing area. So the idea of this lesson is really to help students continue to practice finding the base and the corresponding height. Also recognize that you could use the area and the base to find the missing height. So let's do some quick practice here. All right, so it says with these which three of these parallelograms have the same area as the other? So basically it means we have to do the math. So we have a base of 5, we have a height of 3, so the area is 15 square units. Here we have a base of 3, we have a height of 1, 2, 3, 4, 5, we have a height of 5, so that has an area of 15 square units. Here we have a base of 4 and a height of 4, so it has an area of 16, so we automatically know that that's the oddball out. Here it has a base of 3 and a height of 5, so it has an area of 15 square units. So A, B, and D have the same area, which happens to be 15 square units. So it says, which of the following pairs of base and height produces the greatest area? All right, well, basically all we need to do is multiply. So right here, 4 times 3.5, that's 14 square units. 8 tenths times 20, that gives us 16 square units. You could do 6 times 2.25. Oh golly, that's 12, 13 and a half, 13.5 square units. And then lastly, oh, that's an easy one, 14 square units. So we could see that B has the largest area. So it says here are the areas of 3 parallelograms. So we've got 10, 21, and 25. Use them to find the missing length. All right, well, that's fun. So it sounds like we're going to do some division. So we know that this guy has an area of 10. So area is equal to base times height. We know that the area is 10. We know that the base is 5, but we don't know the height, so we're going to do a little bit of division to find that the height, the missing value, is 2. Here, we're told that the area is 21. So if the area is base times height, and the area is 21, and we don't know what the base is, this 1 does not matter to us right now. So, and we know that the height is 7, so we don't know what the base is, but we know that the height is 7, so that means the base must be 3. So we know that that missing value there is 3 units. And this area was supposed to be 25. So we know that the area is base times height. The area is 25. This appears to be the base. This value doesn't matter to us right now. We know that the height is 5, so base times 5. So that means the base must be 5 because 5 times 5 is 25. So the base is 25 units. Number 4, the Dockland building in Hamburg, Germany is shaped like a parallelogram. If the length of the building is 48 meters and its height is 55, what's the area? So all we're going to have to do, that's easy, is multiply 86 times 55, and that's going to give us the area of the face of that really kind of neat building. That's cool, right there. That is really neat. So they're saying that that building is 86 meters wide, right here, and then it's 55 meters tall. That's really kind of cool. That's really cool. I've never seen that building before. Select all the segments that could represent the corresponding height if M is the base. So right here is our base, and we know that the corresponding height has to be perpendicular. So that would be a base, and so E is a height, F is a height, J is a height, and K is a height. None of the other letters represents a corresponding height. And then I think the last one, find the area of the shaded region. All right, so oh my goodness. So it looks like we're going to do a little bit of subtraction here. We can see that the area of the entire rectangle, this big outside enclosing rectangle, it has a base of 14. It has a height of 10. So the overall area of that enclosing rectangle is 140. So now we need to take a look at these little triangles. So here's one little triangle right here. So we could see that 2 times 6 is 12, but you got to divide that by 2. So that gives us an area of 6. So that means this little guy is 6. And we can see that this guy is the same thing. So he has an area of 6. Using basically the same kind of math, we see this triangle right here has a base of 12 and a height of 4. So 12 times 4 is 48. Divided by 2 is 24. So that has an area of 24. This has an area of 24. So we could take those 24s and the 2 6s, which is 12, and add them together. You get 60. So we're going to subtract from the 140, and we get 80. So that tells us that the area of this orange rectangle is 80 square units. All right, parents and teachers, that wraps up Grade 6, Unit 1, Lesson 6, where students are really consolidating their understanding of parallelograms.